Alright, so I'm recording for Nora. So we took the Excel portion and the CAD portion already. You have 12 points of multiple choice. It's going to be 12 questions worth 1 point each. And then 38 points worth of free response, most of which are going to be like short answer stuff, explain something, whether it be mathematical, something about engineering profession, something about what we talked about with history, something we talked about with ethical engineering, something about the design process. So any of those topics that we've talked about, especially like during lectures, are fair game for the free response and multiple choice. Don't expect, it's not going to be like meant to trick you, but if you don't know your stuff, you're not going to do well. So if you've struggled on some of the quizzes in the past, I recommend looking at them again, looking at your notes from class. What I thought is go over a list of topics today and just ask you guys if you have questions about stuff that might be unclear. Okay, so you're prepared and know what you can expect to be on it. So in the beginning, we started with simply history of engineering. Okay. With that, we talked about types of engineering. So understanding the different main 4 branches that had begun first. Understanding maybe some contributions to engineering earlier in time. Not too much on the history part. Okay. It's not going to be like a history test for you at all. Then we spoke about like what is engineering specifically. And in this section, we talked about what it takes to actually study engineer versus actually becoming like a professional engineer. Okay, 2 very different things. One, like I've mentioned about myself, I studied engineering. I do not have a PE license. I never practiced engineering besides being an intern 2 different summers. But the different aspects of what engineers do as well. So some are really in research and some are in industry. Okay, the 2 main facets there. Let's see. We talked about characteristics of engineers, what the goal of engineering is as a problem solver. So there was a decent amount in what is engineering that we spoke about. And we also had a quiz on this topic specifically. If I ask you something specific, such as a person in the history of engineering or one of the disasters, there's a good chance it'll be something that's multiple choice. So you don't need to start like memorizing names, but you should be familiar with them. So if you saw a name, you should be able to recall where you saw that before. But I'm not going to say like, tell me everything Nikola Tesla did. But you should be familiar with people that we spoke about in class as far as like what contributions in general they had. But you're not going to be asked to like define something or tell me specifically. It would be more in multiple choice for you. Let's see. We talked about just basic engineering math. Oops. And I can't spell either. And in this topic, we talked about concentric circles, tangent planes, tangent surfaces, the basic shapes, different polygons, different properties of polygons, area, circumference, basic trig, area of a triangle given any triangle. What else? You had a quiz on that. That would definitely be something good to study from this. We also talked about right after that, well, this was going into CAD, were the different types of views for like isometric views. And if you remember, an isometric view had to do with taking a look from like the top, the side, the front, and matching up with which orthogonal view it is. So understanding that if I give you like 3 different cross sections of a solid, you would come up with the actual solid it is. I'll give you choices for that because it's almost impossible to do without choices, to actually draw it without some sort of dimensions on there. All right, that's the multiple choice stuff as far as topics for multiple choice questions. Okay, we're going to get to free response. In free response, go back to the different types of engineering, understanding what each does. So whether you're able to discuss what a civil engineer does, a mechanical, a chemical, electrical, those were the main 4. Okay, the main 4 that there are. Obviously, there are like other subcategories. Like, for example, a structural engineer would probably be someone who studied civil engineering. somebody who is a computer engineer really studied electrical engineering, okay, but it's electrical computer engineering. So understanding the main four: mechanical, civil, chemical, and electrical. So give examples of what they may do, maybe examples of famous ones in those categories. We talked about engineering and like failures in engineering. We also talked about like major accomplishments. Being able to explain, maybe if I give you a couple choices of different like engineering failures we talked about, just be able to explain one of them and what the failure was caused from and how maybe it could have been prevented. So things that we speak about in class, but I'm not going to specifically say like, tell me about this one instance. I'll give you a few choices. Okay, so you can tell me about one of them and explain, because I want to hear the explanation more than I want you to just regurgitate the scenario itself. So for example, there was the one in that hotel where the I-beam that was going up to support it, instead of being continuous, had like that little box connection, and then it ended up falling. The people below it, I think it was like the Regal, or the Hyatt Regency, thank you. Where the second level fell and killed all the people. An example of one, but that's not necessarily going to be the one, but I'm going to give you a few choices, okay, for one to pick there. We talked a lot this year about the concept of optimization. What does that mean again? Optimization? Chris? What is it? Barb? Good?
It's like getting the most for your money and being most efficient.
Yeah, being as most efficient as possible. Okay, depending on whether you're looking at an economic standpoint, money-wise, or if you're, say you're an environmental engineer where you want to minimize your carbon footprint, that's optimization as well. But think about minimization or maximization of some objective function. Okay, some objective function. So you want to get the most out of something depending on what the scenario is. We talked about professional engineer, so let me just write that other one down, by the way. Optimization. Okay, we talked about what it takes to become a professional engineer. Just be able to explain that. The two main things of exams and then experience, but go into a little more detail as to what we spoke about in class. We also mentioned, okay, any failures, the main branches. There's going to be something from everything that we spoke about in lecture throughout the year so far. So you could expect everything to be on there. We talk about the design process, and in the design process we talk about modeling. Okay, and we talk about manufacturing modeling, specifically the idea that you're not going to manufacture a product before you really model and test it. Understanding how those models are used, understanding the kinds of models that can be used, giving examples of those. Let's see. The constraints that are involved when it comes to the design process. So what is a constraint? What is a constraint again? Yeah, some factor that limits you. Okay, some parameter really that tells you cannot exceed X, or you cannot, go too. The object cannot be too small, or the structural integrity, fails. But understanding the constraints are things that limit you. Okay, being able to give examples and describe what they are. This pen is terrible. I need to put a new. You should know terminology. Okay, general terminology. So specific things that we talked about, like the term concentric you should know, or understanding, I don't know, what's another example of something that we spoke about this year that's a new word? Entomology. Entomology? Meaning?
Meaning cleverness.
Cleverness. Ingenuity? Is that the word you're looking for?
No.
Entomology? That's the word we spoke about this year?
What word?
All right. Entomology.
Well, it's not on the... So, we're good. Don't worry.
Gave that away. Let's see.
You know what that means? It's the study of insects.
No, I'm telling you, I'm going on
I think we talked about the etymology. Etymology, not entomology.
Okay, same thing.
Yeah, etymology of the word engineering is what we spoke about.
Yeah.
Yep.
Okay. It's not, I swear it was a thing.
You know, I recognized entomology though because I taught forensic science here 2 years ago, and that was one of the terms we used. But when you said entomology, I was like,
I pronounced it wrong, but don't worry. It's a thing.
you should know the basic terms from CAD work. Okay, we took the CAD assignment yesterday, but if I ask you a specific thing, whether it be multiple choice or for response, you should be able to understand what the words meant that we did. So, for example, you know, certain commands or certain features in CAD that are useful. Let's see. So the math work that I spoke about is going to mainly be free response. Okay, it's going to mainly be free response. You could be expected to understand how to calculate, you know, we talked about in class, things like concentric circles and the area of different sections, wall thicknesses, different dimensions of different triangles that you would have to use. So your basic trig. If you don't bring a calculator, you're not going to be able to do the trig portion, so bring a calculator, please. Volume and surface area, simple stuff from geometry that you did in like 10th grade, you should be able to redo, depending on the solid shape. If the solid shape is a cylinder, you got to think about, okay, it's a circle, and it's a rectangle unrolled. If it's a triangular prism, you got triangle, and then 3 different rectangles. If it's a rectangular prism, right, you've got 6 different faces. We talk about volume, right? Volume and surface area. What's the general formula for volume? What's the easy way to calculate volume of any prism? That's for a rectangular prism. That's for area of a triangle. How do you find the volume of any general prism? The reason I ask is because you do it all the time with CAD, actually. Maybe else you're not. What is it? Yeah, the area of the base times the height. So if you have a cylinder with a circle on each end and the same base, if you know the area of one of those circles, you just multiply by the height, always gives you the volume. And that's what extrusion does. It takes the area of the base and you extrude it. So if you have a rectangular solid and you move it to the 3rd dimension, you get, if you have a rectangle and you move it to the 3rd dimension, you have a rectangular solid, which is why it's LW times H. Okay? So if you have a circle at the end, it's pi r squared times H. Whatever the area of the base is times H. Let's see. Mathematically, we talked about rates of change, what a rate of change is, understanding the concept of slope, understanding the idea of units for rates of change. So we spoke about like things like, okay, how mile per hour and meter per second are really the same thing. It's just a different unit analysis. So one has 1 unit of measurement in the metric system, one is in the English system. But there's still a speed or velocity, or volumetric flow rate, gallons per minute. Okay, the idea of rates of change. The idea of rates of change, because specifically in engineering, you're talking about functions or things that change as a function of time. The design process as a whole. So there were 8 steps to the design process. I will most likely either do one of 2 things: give you a product and you have to tell me what the steps would be that go into it. Okay, so for example, like I'm trying to think of a product that would be a good example. All right, how about 3D printers? Before 3D printers were like, you know, more commonly used, maybe 5-10 years ago, what do you think the design process was that went into modeling and making a 3D printer? Okay, going through all the 8 steps. I'm not going to ask you to memorize the 8 steps, like the names of them, but understanding how to apply each step. It's an A. Morals and ethics. Okay, morals and ethics. Why it's important to be ethical as an engineer, the impact or the result of an unethical procedure or something where people obviously try to save, it's usually money, comes back to, right? Save money for themselves at the expense of, you know, the welfare and the safety of others. So understanding the idea behind that. And the concept that, even though engineers aren't somebody like a police officer, bless you, that have to swear an oath, or like a judge that swears an oath, or a doctor, the idea that the implications of what they build could be catastrophic if done improperly, and what the results of cutting corners are. You should understand what factor of safeties are. We talked about factors of safety throughout the year. The concept that a structure, or I don't know, not just a structure, an apparatus maybe, is built with some sort of extra safety in it. So, for example, if it says it can withstand a certain amount of force, it's usually something greater than that in order for, the product not to fail right on the threshold of the limit. So, when you let's see, what are those things? Those hoverboards? They're not hoverboards, but the things that are called hoverboards now? So they are, most of them, like the regular one, my cousins got them for Christmas. So when we were at my uncle's, everybody was flying around the house on these things.
Did you ride them?
I did, yes. They're fun, right? They are kind of fun, I gotta admit. So,
She get one for the class.
what's that?
She get one for the class.
Yeah.
Just get one for the class, yeah?
I should teach on it.
It'd be really funny. Something's wrong around teaching on it. But they have weight limits on them, that's what I was getting to. And the one that they got said like 220-pound weight limit on it. But it's probably not 220, right? It's probably like 300 or 350. It's probably a factor of safety of 1.5, because why? Most people that just get on them don't say beforehand, what's the weight limit on there? People are just gonna actually get on probably if somebody else has them. They say, oh, let me try it. And they get on naturally. So an average person is probably, I don't know, male probably around like 180, 200 pounds. Female between like 150, 180, I don't know, I'm just throwing out numbers. But there are a lot of men that are like 6'3". My uncle's like 240 pounds. And the first thing he said, he was like, I'm not going to get on because he had a certain limit on it. He bought it, so if it breaks, he doesn't have to deal with it.
Like 350 pounds.
What's that?
Like 300 pounds.
The one that they had in claim was like 225, so that's why he wasn't getting on it. I don't know.
Your uncle bought
But, I mean, it still works, obviously. But the idea of the factor of safety is to kind of give you a little wiggle room, right? So you're not coming close to that threshold where an object could actually fail. All right. We talked about God bless you. We talked about liability, and liability kind of came along with morals and ethics. I think so. Liability, more about who's responsible for some sort of a failure. And we specifically talked about some instances of this. But maybe if I give you a case study, or if I make up some sort of a scenario, you have to, deduce from the information who would be responsible possibly, why they'd be responsible. I don't know, that's really what we talked about for liability. Chat, question or discussion? Those are the main topics for midterm. What questions do you have? What questions do you have?
Can we go over one of the concentric circle problems? Like
Sure. The mathematical ones?
Yeah.
Yeah. So let's look at it. Talk about, let's do area, circumference, wall thickness, all those. So let's say we start with, let's say we have copper wire. Oops. Come on. I need a new stylus. Copper wire with insulation. Yeah, copper wire with insulation would have some sort of a shell around it, right? And this is the insulation out here. Now, okay, the concept here is understanding wire gauge. So the thickness of the insulation, the thickness of the wire itself affects how much current it can carry. So scenario, I recently bought my dad a snowblower for Christmas. And we haven't had any snow, of course, this year, right? And I was buying an extension cord. Thanks, Jeff. I was buying an extension cord. And when you buy extension cords for things like not lawnmowers because they're not electric, but this was an electric snowblower. Snow blowers or any sort of high power tool. So if you have like a miter saw in your garage, you want a heavy duty extension cord. So you get what's called, it's actually a lower gauge, the number gets lower, but it's just a thicker inner diameter of the copper itself. So as a result, more cross section of the copper, it can carry more electrons or it can carry more current. If you remember, current last year was measured in amps, we talked about. So here, let's take a look at a scenario where the copper wire